As I said, I'll be presenting like how to do basic stuff with R. I mean GIS stuff with R. I meant to prepare a longer session, but I'm gonna basically show to how to do some maps with different kinds of maps, and then I'll show you how to do some zonal statistics. But for that, I'll be using Quantum GIS because I think it's like a much more efficient software for that. As I said, I'm a Mac user, and as you know, like you don't have access to ArcGIS if you're using Mac, and so I thought it would be convenient just to show you how to do some basic stuff when you simply don't have access to a PC with ArcGIS. And I'm going to start by introducing why I think R is like a good option. Well, first of all, ArcGIS is quite expensive. You all know that, and it's only for Windows users. R is open source, it's free, and it's available for all kinds of platforms. And one interesting feature about R when it comes to mapping is that the simplest maps in R don't require any data files. So what you have in the maps library in R, it's already like a bunch of data and a bunch of maps that you can actually use without using a shapefile or anything. If you just want to show, for example, a simple map and your sampling units of your survey or something like that, it's very straightforward. And that doesn't require any kind of additional data sets. R has a lot of options to customize the maps and to do all sort of spatial analysis. I'm not like an expert on this, and I have some experience with mapping and computing zonal statistics, but not much with spatial analysis. So I'll not talk much about that. And the fifth reason why I think R is quite useful is that you can run the same script and produce the same map as many times as you want. I don't know whether you've been trying to write scripts in ArcGIS, but sometimes it's very crashy. Depending on the version that you have of the software, sometimes you are able or not able to replicate the same map. And you basically don't have this problem with R. There are many tools, all of them, as you know, open source. And I was just searching yesterday for what's new regarding maps in R. And so basically you have now access to all the maps that are in the web, like the MapQuest, the Google Maps, satellite data, everything. So now there are a bunch of very sophisticated packages that you can use to retrieve maps and data from the web. I haven't explored those that much, but what you usually do, what you usually use is the maps library, which is for creating geographical maps. This contains maps for, I mean, like maps of the whole world. There is also the map data library, which contains basic data that go along with the maps library. The map tools is probably the most common to create basic maps to plot data spatially. The map library is to create projected maps, these rounded maps that are supposed to be like a more accurate representation of how the world looks like. You can read raster files, for example, all the data on precipitation and weather, or crop suitability, minerals, etc. All those data that come in a raster format. And recently I've seen that some people create maps using ggplot. As you know, ggplot is a tool in R that creates very fancy graphics. And I recently saw some maps in ggplot, so I thought it was interesting also to show how to create those. And then there is this library GPClip, which is like a general polygon clipper that basically extracts the information from the shapefiles so that you can use them with ggplot. Okay, so I'm going to start by showing like very simple maps. Probably some of you have some experience, and it's going to be very basic. But in any case, so for example, in here to create this map, I only require to load the maps library, the map data library, and then using the map function, I'm specifying that I want to plot Mexico from the world hires data set that is contained in the map data library. One important instruction to give in this command line is to be precise on the coordinates. So basically, this function will map whatever you want that is contained between these coordinates, right? So I'm specifying here that I want to plot Mexico from this data set, and to be able to show the map, I need to restrict my latitude from -118 to 14.5, and then the longitude from -86.7 to 32. So, you have a question?
Yeah, where did you find, you just went on a map and you found the actual coordinates?
Well, you have to have a sense of where the country is located or the city, and then based on that you restrict your coordinates in this way.
The big coordinates of like a polygon around the map.
Yeah, so basically I'm just saying this is going to start here,
Okay.
and it's going to end there. So that square, the square contained among those coordinates is going to be the area.
The beautiful thing is, if you get it wrong, you can easily just edit this quite easily.
Yeah.
So you're trying to put Mexico on Indonesia.
Yeah, yeah. Yeah, and also like to do zoom in, zoom out, and add other country, it gets very easy. That's one like straightforward advantage over, for example, ArcGIS. That if you want to do that, it's not that straightforward. Here, literally, you need these 3 lines and load those libraries, and you can plot any country. And here I specify I want it blue and fill equals true because I want to fill the polygon with this color, otherwise it's going to look like a transparency. Here is another example that I found from the R bloggers, which I thought was interesting. Here they are plotting Canada from the same database. And again, like just changing the color and restricting the coordinates accordingly. But if you want to do like a zoom in the map, you just change the coordinates. And if you want to go very close to a specific city, the quality of these maps is good enough so that you can show that. Now, these libraries only contain the maps and some data that probably you will never use, or that is not useful for our research. So usually you will have to combine your attributes table, to merge your attributes table to the shapefile or to these maps or whatever, right? So if you have worked with shapefiles, you know that the way it works is that you have the shapefile, which is basically like, for example, for a country, it's like a map with the polygons of the administrative boundaries. You want to fill those with data. You have the data set is aggregated at the county level and have to merge those 2 files so that you can actually plot them. That's also very straightforward in R, and you could even also do it using these maps. The map tools function will allow you to read different kinds of shapefiles. I'm going to explain later a little bit more about what's inside of a shapefile, but At this point, it's important to know that a shape file in form of a polygon is, for example, the administrative boundaries of a country or the polygons of national parks in the US or any sort of polygons that you have in a map. Then you have shape files that are lines, for example, those indicating rivers or roads. And you have also shape points, which is basically just the coordinates, a dot indicating specific coordinate. So with this library, you have to use these different functions according to the kind of shapefile that you are using. So if you have a line shapefile and are using the shape poly function, it's not going to work. Now, you could also have, for example, GPS points in a CSV file or in a TXT format or whatever. You could also read that data in R and put it in a map. So basically, you would read it the same way you read any other CSV file. But for plotting this data, you have to create two columns individually, one for the latitude and the other for the longitude. And the coordinates, that's quite important, have to be in decimal degrees. So for example, in this map, they are using, again, the two libraries that I mentioned before, plus map tools. And they are gonna plot, I wish I had like a more political science example, but in this case, they are gonna plot the natural range of pine. And then like the location where they conducted the field work. So, for example, they are using the pine count shapefile, and they are storing that in this object. So you just use this function to read that shapefile, and then to read the fieldwork samples, which are GPS coordinates, you just use the read function, specifying that it's a CSV file, and create the object for the sampling units. So how we will proceed to create like a map that is adding layers and layers. First, we will plot the baseline map. In this case, for example, Canada or one particular section of Canada. And then we will plot layers or data onto this map. We will add the shape files that we have. In this case, for example, the natural range of a specific tree. And then we will plot the place locations where the fieldwork was conducted. And then you can, of course, incorporate like text and a bunch of things. I'll show you the code now, but one thing that is important is that when incorporating the layers, you have always to specify add equal true in the function for every step after plotting the baseline map. So here we have the map that I presented before. It's just basically taking Canada from the World Heritage dataset and a specific part of Canada. In here, you can see an additional feature of this function. We are incorporating the part of the US that is within the same coordinates restriction. So that's why it's important that you specify the country in here. And you can see here the border. Here we are incorporating the polygon shape file, which is showing the natural range of this pine. And basically what we are doing is just using the plot function. You remember that we created this object based on the shape file. We type add equal true and the same restriction of the coordinates, and we specify the color the way we want. And if we want to incorporate sampling the GPS points, we do the same, just using the points function. We are getting the latitude and the longitude from the SAMPS CSV file that we stored. And we we just put the color that we want. And then you can incorporate, for example, this scale with the kilometers, distance, and stuff like that. Okay, so these maps are like very easy to create, and I really wanted to show those because for some basic tasks they are very, very helpful. For example, when I was just doing fieldwork, I was able to create to map the sampling units of my survey like in 2 minutes, right? Just having the coordinates without going through all the process of downloading a shapefile, etc., etc. You just have R, and even if you don't have any shapefiles, you can do it. Now, there are, of course, more complicated ways of generating maps in R. And to start, it's important first to take into account that a shapefile, I mean, we usually refer to a shapefile as one single file that it's like a map. But in fact, like a shapefile is a bunch of at least between 3 and 6 individual files that store different kind of information, and that when you put them together, it creates like a map. So we have the SHP file, which is the actual shapefile, the one that is like in geometric form. Then we have the SHX file, which is like just an index for the position of the polygons. And this is quite important, the DBF file. This is where your attributes are stored, right? So if you open a shapefile in any software and want to see the data, you cannot see anything, right? You will just see a bunch of coordinates, and you will not make any sense of what's in there. So if you want to see the actual data, this is a place where you want to go.
So is it stored as a list, or?
The DBF, yeah.
The whole set of it? Is there one list of all the shape stuff, or 3 lists?
For you mean for the 3 files?
Well, you have 3 types there. Is that one big list of 3 sub-lists?
Yeah, so it's basically one of them contains the polygons, the other the position of the polygons, and the other one the data.
Is it
So
one list or 3?
it should be 3.
3 lists.
Yeah, I mean, yeah. Yeah, so this is like just like a data table, right? I mean, like a CSV table. So we have columns for the attributes of each polygon in the dataset. So if you have a raw shapefile without any content, like any attribute, and you want to merge some like attributes into that shapefile, basically what I found most efficient is to manipulate the DBF associated to that shape of file, which is the one that contains the attributes. So to do that, for example, in here, I have a shapefile of Mexico, and I wanted to merge in the homicide rates for each municipality in Mexico. So I just set my working directory. Then I create an object that is going to be the data frame, which is going to be retrieved from the DBF file associated to the municipio's shapefile. You okay? Then I'm going to load the attributes data, which I have in this case in Stata format. So it could be CSV, Stata, or any format. And create an object called killings. Yeah.
So the DBF, you said it's without attributes, so it would just be a column with
An
each
identifier.
observation would be one municipio.
Yeah.
Okay.
Yeah, actually, that's important. To be able to do the merging, you need an identifier, right? So you have to explore the DBF file and see how it's organized. and probably just create the same identifier for your data, for your table of attributes.
Data.
Yeah. So here I'm just creating the killings attributes. Then I'm going to use the merge function to combine these two data sets. So I'm basically merging, this should be just killings.
And that should have the same name. No?
Yeah, this is killings and this should be killings in here.
Oh, right.
So I'm merging the attributes table with the data frame. I mean the DBF with the attributes by an identifier that I have in both tables, in both data sets. And I'm gonna call this object joint. And now you can rewrite the shapefile, I mean the DBF file, so that when you plot the shapefile and look at the attributes table, you will see all the variables that you just merged in. But that means that your DBF file was modified, and you may want to save the older version. So what I always do is to save the old version, so I always keep the original DBF file, just in case I want to go back or that something went wrong. I first saved the DBF file as the old municipios. And you can do that like the same way you save like a data set for a state or whatever. Just write .dbf and specify that you want to save this, the frame. The frame that is this one, not the one that was modified, as all municipios DBF. And then the new one, which is called joint, I'm gonna save it as municipios.dbf. So when I load the shapefile, I will be able to retrieve the attributes that were just merged. And this, if you have like a similar script, you're combining a lot of data, you can do that very, very quickly, as opposed to trying to do the merge in ArcGIS, which is like a bit tedious.
So you have to give to the modified DBF file the same name as the original one.
Exactly.
So okay.
Exactly, because when you load the shapefile, it's going to be associated to a DBF file with the same name.
So the DBF file is just a data frame?
Yeah, it's just a data frame. Yeah.